So we're going to look at two things today. We're going to look at how we combine like radicals when we add and subtract, and then we're going to talk about how we multiply radicals together that are binomial expressions. So when we combine like radicals, we're not really adding them together. The sum of any two real numbers is a real number. So for instance, if I can add the square root of 2 and the square root of 3, and I get a real number, but it's the square root of 2 plus the square root of 3, which is not to be confused with the square root of 5. So I can add 2 square root of 2 plus 3 square root of 2 and get 5 times the square root of 2. So when we add what we call like radicals, the like radicals are radicals that have the same index and they have the same radicand. But when they don't have the same radicand, then we cannot combine them. Even though we can actually add them as two real numbers, we can't actually combine them when we simplify. So what is the simplified form of 3 times the cube root of 5x minus 2 times the cube root of 5x? Well, it would be 1 times the cube root of 5x, because notice they have the same index and they have the same radicand, so we can combine them. So what we do is we subtract the coefficients. The next one says 6x times the square root of 7 plus 4x times the square root of 5. So notice this part is not exactly the same because those two square roots do not have the same radicand. So we cannot combine them. So we say that this is already simplified. The same thing with the next example, 12 times the cube root of 7xy minus 8 times the fifth root of 7xy. So even though these two radicals have the same radicand, they do not have the same index. So we cannot combine these either. So we say that this is already simplified. But if I see 3 times the cube root of 7xy minus 8 times the cube root of 7xy, I notice that the radical part is exactly the same. The index is the same and the radicand is the same. Therefore, I can combine them by subtracting the coefficients and keeping the radical part the same. So it's going to be 4 times the cube root of 7xy. So when we see radicals that are not the same, sometimes we can simplify before we notice that they actually are like radicals. So for example, the square root of 12 is the same thing as 2 times the square root of 3. And the square root of 75 is the same thing as 5 times the square root of 3. And then we have 1 times the square root of 3. So we actually do have like radicals here. So we can combine them. So we're going to add and subtract the coefficients. 2 plus 5 is 7. 7 minus 1 is 6. So I end up with 6 times the cube root of 3. Notice the radical part stays exactly the same, just like when we add like terms. Okay, so that's the first thing. The second thing we're going to look at is what we do when we multiply binomials together with radicals, and what do we do when we divide. So when we multiply binomials together, we know we use the FOIL method. So I can do first, outer, inner, last. 4 times 5 is 20. 4 times 4 square root of 2 would be 16 times the square root of 2, plus 2 times the square root of 2 times 5 would be 10 times the square root of 2. And last would be 2 times 4 is 8, and square root of 2 times the square root of 2 would be 2. So 8 times 2 would be 16. So when I multiply 2 times the square root of 2 times 4 times the square root of 2, I get 8 times 2, which is 16. And after I distribute, I always add my like terms. So I have 20 plus 16, which is 36. And 16 times the square root of 2 plus 10 times the square root of 2 is the same thing as 26 times the square root of 2. Okay, let's do one more like that. When we multiply 2 minus the square root of 7 times 2 plus the square root of 7, we notice that these are special products. They are actually conjugates. Does everybody remember that word? Conjugates. Conjugates. Exactly the same, except the irrational part has a different sign. So when I multiply conjugates together, remember, special things happen. So let's see. We're going to do first, 2 times 2 is 4. Outer would be 2 times the square root of 7. Inner would be negative 2 times the square root of 7. And last would be minus the square root of 7 times the square root of 7 is 7. So notice the outer and the inner are exactly the same but opposite. So when we add those together, we get 0. And we add 4 minus 7, and we get negative 3. So notice when we multiply two conjugates together, the product is actually rational. So now we're going to look at a couple of examples where we divide by a binomial expression that has a radical in it. So we know that we can't have a square root in our denominator, so we need to rationalize. So we rationalize by when the denominator has two terms. We rationalize by multiplying by the conjugate. So the conjugate of the square root of 5 minus the square root of 2 is the square root of 5 plus the square root of 2. And whatever we do to the denominator, we have to do exactly the same thing to the numerator. So we have some multiplying to do. Let's see. In the numerator, we're going to distribute. So we get 3 square root of 2 times square root of 5, that would be 3 square root of 10, plus 3 square root of 2 times the square root of 2 would be 3 times 2, which is 6. In the numerator, we need to do FOIL. So I'm going to do first, square root of 5 times square root of 5 is 5. The outer, remember, when I multiply conjugates together, the outer and the inner are exactly the same, but opposite. So we don't really have to worry about doing the outer and the inner. We know those are going to add up to 0. Those are going to cancel out. And then last, we have negative square root of 2 times the square root of 2, which is negative 2. Okay, so let's see. We get 3 square root of 10. It's not 10. 3 square root of 10 plus 6 all over 3. And then lastly, what we're going to do is we're going to look to see if we can simplify our fraction. So we're going to look at the 3, the 6, and the 3. The 3, the 6, and the 3 are all divisible by 3. So I'm going to divide everything by 3. So I get 1 times the square root of 10 plus 2 all over 1. So I don't need to put that over 1. Okay, we're going to do that one more time. Excuse me. We have in our denominator, I see the square root of 27, and I know I can simplify the square root of 27. So I'm going to rewrite 4 plus the square root of 27 as 4 plus 3 times the square root of 3. And then I'm going to rewrite 2 minus 3 root 27 by writing 2 minus, let's see, that would be 3 times 3. So that'd be 9 times the square root of 3. 3 times 3 times 3 times the square root of 3. So now we're going to multiply the denominator by the conjugate of 2 minus 9 times the square root of 3, which is 2 plus 9 times the square root of 3. And we're going to do exactly the same thing to the numerator. So it looks like we have a lot of multiplying to do. So let's do the numerator first. So I do first, 8, outer, 36 times the square root of 3. Inner would be 6 times the square root of 3. And last would be 3 times 9 is 27. 27 times 3. 27 times 3 is 71. Nope, it's 81, sorry. And then in the denominator, I'm going to do FOIL again. But remember, I'm multiplying conjugates together, so I'm not going to do the outer and the inner. I'm just going to do the first and the last. So 4 and then minus 9 times 9 is 81. 81 times the square root of 9, that would be 3. So 81 times 3 would be 243. Let's see, let's check our work here. So we got 9, there we go. Okay, so now in the numerator, I'm going to add my like terms. 81 plus 8 would be 89, plus 36 times the square root of 3, plus 6 times the square root of 3 would be 42 times the square root of 3, all over 4 minus 243, which would be negative 239. And the last thing we want to do is we don't want to leave our denominator negative, so I'm going to change the sign. So I'm going to make 239 positive. I'm going to make negative 89 and then minus 42 times the square root of 3.